Okay, so now I'm sharing my screen, and the few shots are actually examples of buildings that have inspired me. So to the left, we see two slides. They show the Shuchoff Tower. It's a really lightweight structure from the 1920s. And then we see the Pantheon building, a very clever way of building a long span. And then we see here two grids, and one is Zaha Hadid's hotel, and the other one are Pierluigi columns and a grid concrete structure. And they're very different, whereas one follows the forces, the Pierluigi Nervi one, Zaha Hadid is only possible because of digital tools that allow us to build anything today. And then my fascination for geometry and form, and this is Utzon's Sydney Opera House and how he form finds using a sphere, the sails of the Sydney Opera House. For a long time, I believed, and I still believe, that it's very important to have a collaboration between engineers and architects. This is a sketch by Corbusier, where we see the two hands coming together. So the work of an architect and an engineer have an overlap, and they have to collaborate. Since this has become very much part of a book that I wrote on conceptual structural design, but also my views have changed a bit, that now I don't think that it's enough to have a collaboration between an architect and an engineer, but the craftsman is really important, yeah? So if we're going to build sustainable buildings, then architecture, structural form, and realization come together and are very important. A recent book that I've just published is about physical modeling, and I've worked a lot with physical models in my life, and the previous work is on reciprocal frame architecture, and I bring them together because both are developed through models. And we use a lot of models in education. They're really important for architects and engineers because I think especially for architects, because they don't have the background in math and to understand the depth, but also for engineers because you can see immediately what happens. But actually the book was about explorations of, are physical models important still today in practice, not in education. But coming back to education, our students make a lot of physical models. Here are some columns where we're not only concerned with the forces, but also with the aesthetic and how better to understand bending active than through a model. Here we see some apples that when they rot, the bending becomes they become lighter and the bending forces are smaller. So the bending in the column will change. So a lot of things can be seen and understood through models. They're again student work here. But my own work with reciprocal frames was also developed to a huge degree with physical models. And that was because computational tools at the time were not at the level to be easily used. Of course, I use computation, but not so much to generate geometry, but more to draw. Today, we have parametric tools that allow this a lot more easily. Even though we have all this, I still believe that physical models are a good tool to have. So with students, we built a lot of these models where we explore geometry and how they can come together. So reciprocal frames use, the ones I work with always use identical elements that come together in a simple way to create complex geometries and large spans. A project that I would like to share with you is inspired by Leonardo da Vinci. It is a project for a local building in Denmark, and it was the client had a wish to build a farm building, a barn where he would use local timber, not very good in quality, but a structure that's beautiful, that can span a long distance, that has a distinct aesthetic, so kind of too many requirements. So it started with Leonardo da Vinci's drawing, And then it developed into this truss structure. So it's not a true reciprocal frame, but it's based on a reciprocal frame. It is a 16-meter span building, and the wood is really optimized. It could become something else later. It's almost a shame that the cows live in a beautiful form. It would be also equally nice for a little concert hall or a community building. But at the same time, I'm very happy that I was involved, because we could develop something that could be easily built and was optimized in how we used resources. Another project together with colleagues from Belgium was the development of reciprocal frames into bending active structures. They had worked a lot with bending active, but not with reciprocal frames. And myself, I had done a lot of work with reciprocal frames, but not really with bending active structures. So we had a possibility where we could collaborate, and we had just over a year, and we decided that we would build something in full scale. So it started with models, that then we developed this kit of parts that we created these curved plywood beams. And then we built this little pavilion. You see all the members of the team together with myself, my colleagues from BUB, from Brussels, and 2 students from the Technical University. What was interesting to me was that this structure that is truly minimal, it's using only 12 millimeters of plywood to span about 5 meters, was not only beautiful, but also very easy to put together. And then at one point there was a rock festival, and we were invited to have it there. So in a couple of hours, it all came down, and there was nothing left on the site. It came in a little, it was packed down, and it could leave in this little van. And so that has inspired me a lot. And together with some colleagues from the Nordic countries, we're exploring ways of how to use materials that are not so obvious to use. So we have, based on another form of reciprocal frames, this is a real building in Copenhagen. It's a station. So if you look at the timber roof, it's actually a design, a German design by an engineer called Zollinger. So we are exploring with this type of structure how to create connections that are very simple, but we're trying to utilize materials that are otherwise waste. And then the other aspect that I'm really interested in is that we look at what is the cultural value of these materials. Coming back to physical models, through the book, I clearly found out that physical models had been used a lot throughout history, like in form finding of St. Paul's, for example, or we knew about Gaudi's work. But my question was, like, how are they used today? Today we live in a digital society. One can't imagine our lives without digital tools. But the journey went further throughout history. That was also really rewarding, because we could find out how physical models were used, and they had different roles in the projects. I love this by Frei Otto, Thinking by Modeling. But in more current project, like in Sambuichi's project, the Roca Mount Observatory, the geometry was generated clearly through computational tools, through many iterations. But without models, they could not be sure that they would be able to put it together. Also, a lot of models were used to explore how the snowflakes will land and stay on this lace structure. A project that's now under construction is this water culture house. I don't know if you can see my cursor, but that's the School of Architecture. So it's very close to us. It's a bath, it's a spa building, designed by Kengo Kuma architects and Zoran Jensen engineers. And clearly it's like a building at the forefront that couldn't have been designed without computation. So I was a little bit worried when I talked to the designers if they had used physical models. And what was really powerful that came across is that physical models are more important than ever. They're very different to what we know throughout history. They're now digitally printed, but they allow us to collaborate in the design team better than ever before. The book presented different roles of physical models. And again, it has 3 case studies. One of them is devoted to Mamoru Kawaguchi, one of my greatest heroes at IASS. Unfortunately, he did not live to see the text, but he's in the book. So that was a little moment about me.